Okay, let's start with the LCR circuit. So, an inductor, capacitor, and resistor, they are connected in series to an AC voltage source given by V is equal to V naught sine omega t. This source will provide a current I as these three elements are connected in series. So, the current through all of them will be same. The voltage across the inductor is given by VL, that is IXL, where XL is the resistance. We call it to be inductive reactance that is offered by the inductor. Similarly, across the capacitor, the voltage is given by VC, and across the resistance, the voltage is given by VR, that is equal to IR. Now, definitely we know that the VL, VC and VR won't be having the same phase. That is, जिस instant पे VL अपनी peak value पे होगा, at that instant VC won't be at its peak value or VR won't be at its peak value. Okay, that means that at any instant the applied voltage V, that is being given as the phasor resultant of VL, VC and VR. There's a phasor resultant there. So let's draw first the phasor diagram there. Say what is common is I through all of them. So we will take I on the x-axis. So we have taken I on the x-axis. In an inductor, the voltage leads the current by pi by 2. So VL should be ahead of I by 90 degree. In a capacitor, the current leads the voltage. So VC should be here. And in a resistor, the voltage and current are in the same phase, so that's the VR in the same direction as I. Now we have to find out the phasor resultant of these three. So first what I will do is I will take the resultant of VL and VC, and that will be depending on whether VC is greater or VL is greater, and that will be decided by the frequency of the AC source. As we know that for very low frequency of AC source, XC will be greater than XL. We know that XC is equal to 1 by omega C. So suppose if you take omega as 0, then in that case XC will be infinite there. So for very low frequencies of AC source, capacitor dominates and its reactance is greater than the inductive reactance there. So if XC is greater than XL, definitely VC will also be greater than VL. Why? Because I is common. So VC will be greater than VL. So if I will find out the resultant of these two, then that will be here VC minus VL. And the resultant of VC minus VL and VR will be here. That's the V, which is nothing but the applied voltage. Correct. So V, the applied voltage at any instant, is being given as under root of VC minus VL square plus VR square. Okay. So if you solve it, then I can take I common, then I, and in the bracket what comes out to be is XC minus XL whole square plus R square there. अगर आप इसको एक स्टैंडर्ड रिलेशन से कंपेयर करें, दैट इज V is equal to I into Z, then V is volts, I is current. So what is left out else other than V and I? That will be nothing but ohms. That's the total resistance, the collective resistance offered by these three elements to the flow of the AC current. So that is Z, that's impedance of the circuit, impedance Z. So the impedance of this LCR circuit is simply XC minus XL square plus R square. And in this case, if you see that this is the applied voltage and this is the current being supplied by this applied voltage, and here the current is leading the voltage by an angle theta there. So in this circuit, I leads V by theta there, and simply we can find out this theta very easily. In this triangle, just find out tan theta is equal to this by this. So perpendicular is VC minus VL by VR, or simply this also can be written as tan theta will be equal to I will be cancel out. So that is XC minus XL by R there. So we have found out theta also, that is the phase difference between the current and the voltage. We can find out the peak value very easily, peak value of AC current very easily. I naught is equal to what? Peak value of voltage by Z. Z already we have found out here. Okay, so now we can just simply write down the equation for current. So current is simply given by I is equal to I naught sine of omega t plus theta, because the current is leading. So voltage is given by this and the current is being given by this there. This is the first case, that if the frequency of AC source is quite low, then in that case simply we find out that the current leads the voltage by an angle theta, the impedance is this, so everything is being found out very easily there. If the frequency of AC source is for high frequency of AC source, in that case XL will be greater than XC there, because for high frequencies, so second case, for high frequency of AC source, XL will be greater than XC, then in that case VL will be greater than VC. So the resultant of VL and VC, that's your I. This will be now VL minus VC, and this will be VR. So resultant of these two will be nothing but it will come now here. That's the applied voltage, and this applied voltage is simply given by under root of VL minus VC whole square plus VR square. So if I will take that's the applied voltage there, that's the phasor resultant of these three things there. So I can write this thing as V is equal to, I can take I common, so that will be under root of XL minus XC whole square plus R square. And on comparing this with the standard relation V is equal to IZ, you will find out that Z, the impedance in this case, will be given by under root of XL minus XC whole square plus R square there. And we can find out very easily the peak value of the AC current is simply given by V naught by Z. Now in this case, if you will see, then the voltage is leading the current by an angle theta, or we can say the circuit is inductive in nature. So voltage leads current by theta, and this theta we can find out very easily. Tan theta is simply given by in this triangle, again right angle triangle there, you can just find out it's VL minus VC by VR, or simply tan theta will be XL minus XC by R. So by this way we can find out the phase difference also between the voltage and current, and then at last we can write down the equation for current is simply given by I is equal to I naught. I naught is the peak value which we can find out from here, sine omega t minus theta, because here the voltage is leading the current by an angle theta. So this is the equation for current there.